Okay, we are going to continue on with volume today. Yesterday we took a look at prisms and cylinders. So today we're going to look at pyramids and cones. Tomorrow in class we'll take a look at a hands-on that will help us develop these formulas. But today we're going to just put them in place, use them, and then we'll see where they come into play tomorrow. So let's start off with pyramid. We know that the volume is cubic, so remember your units are in cubes, is 1/3 big B times H. And we can find that on our Ames reference sheet. Again, remembering that big B, capital B, means the area of the base. Since we're dealing with pyramids today and cones, we only have one base. Height is defined as the perpendicular from the vertex perpendicular to the base, and since we are assuming all of these are regular polygons as our bases, it will hit right in the center of the base. That's all there is to it. Remember that we can apply this to oblique pyramids as well, and let's do that. Find the volume of the pyramid with a regular base. So we're going to assume they're all regular. We want to always start off with the formula. Volume equals 1/3 big B times H. H being the perpendicular. Since I have an oblique pyramid, it shifted my perpendicular from the vertex perpendicular to the base is outside. So my height automatically is 10. So I'm going to go put 10 in here right away. And then 1/3. Big B is the base area, the area of the base. If I take a look at this base, we have 1, 2, 3, 4, 5, 6 sided, so we have a hexagon. And I know that I'm going to have to go find the area of this hexagon. So I know it's 1/2 A times P. A being my apothem, P being my perimeter. So I can take a look, 1/2 times, or 1/3 times the area here. So let's go figure out what that area is, and then we can substitute it in. So B is equal to 1/2 AP equals 1/2. Apothem is the perpendicular from the center, perpendicular to the side, so we need to go find that. But perimeter is just the perimeter of the base. P is going to equal 4 times the number of sides, so 4 times 6 is 24. So I know I've got my 24. I just got to figure the A piece that I can substitute in here. The apothem is going to come from, when I drop from the center to perpendicular to the side, I form a right triangle. The apothem not only cuts my angle in half, my central angle, it also cuts my side into half. So I know that's going to be 2. It's 360 all the way around divided by 6 equals 60, but the apothem will bisect that angle, turning this into a 30-degree angle here. So I see I have a 30, 60, 90 triangle. I know that the perpendicular piece is the apothem. It's also opposite my 60-degree angle, so it's the long leg. Long leg is equal to short leg rad 3, so we know that my apothem is 2 rad 3. Inputting 2 rad 3 times 2 rad 3 for the apothem. 1/2 and 2, those cancel out, so I know my total base area is 24 rad 3. I found my B separately, so I'm going to go insert it into B over here. Rad 3, and still carry down the height. And then I can just go ahead and simplify. 1/3 of 24, that's 24 divided by 3, that's 8. 8 times 10 is 80. So the exact volume is 80 rad 3 inches cubed, which is approximately 138.6 inches cubed. Okay, more of the same stuff we've been doing. Finding the pieces that apply, making sure you're finding the correct pieces. So this is the Louvre in France, dying to go there. And on top of it is a square pyramid. it has a height of 21.64. So since it doesn't say slant height, it says height. That means it's perpendicular down to the center of that square. That's my height, 21.64 meters. The side, or the base side of the Louvre is, we can't read it, it's 35.4 meters. And it's asking us for the approximate volume. So we don't need to find the exact, we just need to find the approximate. We start with the formula. Volume equals 1/3 big B times H. Big B is the base area. 1/3. I'm going to drop my H in because I already know my height from the vertex perpendicular to the base is 21.64 because they gave us. We know it is a pyramid. It's a square pyramid. So to find the area of a square, it's side times side or side squared. So I'm going to substitute in 35.4 squared. And then it becomes a calculator. I should, since this is on my numerator, who cares? This is all up top. 35.4 squared first times 21.64. Hit my enter button and then divide by, the only thing in my denominator is 3. So I should get approximately 9,039.5 meters cubed. Again, we'll derive this formula tomorrow in class. What is the volume of a square pyramid with a base of 40 and a slant height? So this is no longer the height of the object, it's the slant height. But we still have a square pyramid, so I'm going to slant it just so I can get my three-dimensional. So I've got a square. Then I'm going to put my triangular faces in. There'll be 4 of those. That's horrible looking straight line. That's the bottom of my pyramid. It tells me the base edges are 40 and the slant height. So the slanted height must be the height of one of the faces. That's my slant height of just that triangle. That, my friends, is what they tell us is 25. Volume, what's if volume equals 1/3 big B, which is the base area, times the height. So there's some things I got to find. The big B is the base area. It's a square. So I know that's 40, so this must also be 40. So I know the base area is side times side. So I'm going to substitute in the pieces I know. So 40 squared. And then I got to find the height. This is not the height. This is the slant height. The height drops from the vertex perpendicular. So I end up with a triangle that has the slant height as the hypotenuse. The height is what I'm trying to find, and because it is a right polygon on the bottom, or a square, this hits me right in the middle. So I know that this leg over here is half of the whole side. So that's 20. Since I have 2 sides of a right triangle, I should use the Pythagorean theorem to find the third. I know h squared plus 20 squared equals 25 squared. Algebra kicks in, so h is going to equal the square root of 25 squared minus 20 squared. If I put that in my calculator, I get the square root of 225, which is 15. I now have my height, which goes into my original equation. You've got to get used to moving over to the side, finding your missing pieces. In my numerator, I have 1 times 40 squared times 15, all divided by, the only thing my denominator is 3, and lo and behold, it's 8,000 feet cubed. Don't forget, we're dealing with volume. Pause the video, try the next one. Sketch picture, make sure you're finding your pieces. Alrighty, that's what you should have gotten for your volume. If you did not, rework it, see if you can figure it out. Make sure you're identifying in your figure too, the correct stuff. If not, then come to class tomorrow and we'll take it up. Alright, essentially we have an understanding. We're going to see this tomorrow again when we hands-on come up with these formulas. But what you'll see is that the volume of a cone is related to volume of a cylinder. Makes sense because both of them have a base that is circular with same base and height. This is true for our pyramids and our cubes as well. So what we have is one cone plus another cone plus another cone will fill up this cylinder that has the same base area and the same height. So 3 of them go into this cylinder. So the cone must be 1/3 of the cylinder. And we've already dealt with the cylinder or volume of a cylinder. So we know that the volume is equal to 1/3 the base area times the height. But we're dealing with a cone. Since we're dealing with a cone, the base is always a circle. So the base area is always the area of a circle. So we know that the volume is equal to 1/3 area of a circle times the height. We should note too, what's kind of cool, and we'll take a look at this again tomorrow, is that a cone-shaped structure can be particularly strong. Since the downward forces at the vertex are distributed to all points on the circle base. So if I apply pressure here, it's going to distribute and even out that pressure among that whole circular base. So that's why they're particularly strong. What else would this apply to then? We're also going to see the same rationale in our pyramids. Yeah. We'll take a look again at that tomorrow. But let's take a look at finding some volumes of cones. Okay, easy enough. These should be easy because we have a formula. What's difficult is making sure you get all the correct pieces in that formula. So we should always start with a formula. We're looking at it, oh, it's the base area, it's calling the height. Base area is equal to a circle, so I know it's a cone. It's not a whole cylinder, so I got to get rid of all that. So it's 1/3 pi r squared times h. Start substituting in the pieces that you know. R, the whole diameter is 14, so my r is 7 squared, times my height. Height. Height is defined from the vertex perpendicular to the base. That means I don't know what my height is yet. So I do see, though, that I have a right triangle here. I'm going to pull out this right triangle. So over here, I have a right triangle. They told me this angle is 32 degrees. It's a right triangle. And I know that from the center to the side is the radius of the circle, so that's 7. The height is hanging out here, this perpendicular piece, which is what we need to find to put into our original equation. It's a right triangle, but I only have one side, so I can't use Pythagorean theorem. It's not 30, 60, 90, so I'm left with my tangent ratios. I've got my trig ratios. I got TOA. Reference angle is here, so I have the opposite, which is O, and I have one next to it, which is adjacent. I have an O and an A, so I need to use tangent. I know tan of 32 is equal to the opposite, which is 7, over the adjacent, which is h. We need h by itself, so we know that h is equal to 7 over tan 32. Now remember, don't simplify at this point. Put it into the equation. And then simplify as we go. So we've got 1/3 times 7 squared. 7 times 7 is 49. So I'm going to simplify that first. I got 49 over 3 pi, still times 7 over tan 32. I can still simplify across my numerator and my denominator. 7 times 49 is 343. My denominator is 3 times tan of 32. So I gotta leave it as 3 times tan of 32. And don't forget your pi. That is my exact answer. But that doesn't mean anything. Doesn't tell us anything. So let's get an approximate in there. In my calculator, being careful how I enter it into my calculator because of order of operations, I probably need to put parentheses around my 3 tan 32 when I divide. And I get 574.8 cubic yards. Okay, not so bad. The next one is called a composite solid. We're going to do a lot of these in class. We're going to see that I have a base and a width and a height that's all the same, so I must have a cube. But I have a cone that is removed out of my cube. So I need to subtract. When you go down and do your practices at the end of this video, you're going to see that you have a cylinder and a cone. So instead of subtracting this composite figure, you're going to have to add. So let's take a look at how we set these up. So again, I'm going to start with setting up and telling myself what I need to do so I can eliminate some areas. I know we're looking for volume, so I want the volume of a cube, which is a volume of a prism. And I'm going to subtract the volume of a cone. Once I know what I need to do, then I can substitute in the formulas. The volume of a prism is big B times H, right off my Ames reference sheet. Big B being the base area times the height. Minus the volume of a cone is 1/3 pi r squared h. Then it just becomes a matter of substituting in what I need to substitute in. The base area is a square, so I've got 5.1 squared times the height, so that's my base area, times the height of 5.1. It's a cube, so we know it's 5.1 cubed. Minus 1/3 pi r. So r, because my cone sits right inside my square, that's just going to be from the center to the side, so it's going to be half of my 5.1, which is 2.55 cubed. And my height then is the top of the cone down to the bottom of the cone. Well, that's the same height as my cube, so it's times 5.1. Then it just becomes making sure you're careful with your calculator. You should be able to put this in exactly like you see it, except for you probably need parentheses around this 1/3 so that it's doing it correct. Otherwise, 5.1 squared times 5.1 minus parentheses 1 divided by 3 times pi times 2.55 squared in my calculator times 5.1. And we are going to get an approximate volume of 97.9 meters cubed. You should probably pause the video and then put this in your calculator. Make sure you can get that so you know how you're working your calculator. All right, last one before you guys work on your couple practices. The covering on a TP rests on poles that come together like concurrent lines. Remember, there's a good word. Concurrent means where they all overlap at some point. The resulting structure approximates a cone. If the TP pictured is 12 feet high, so remember when it's defining height, it's talking about perpendicular to its base. So that's my height is 12. With a base diameter, so the whole thing is 14. What is the approximate volume? Which makes our life easy because we can just approximate it. Volume, particularly of a cone, is 1/3 pi r squared, because that's the base area, times its height. Substituting in the pieces, I know. Pi r would be 7 squared times height, which is 12. 49 times 12 divided by 3 times pi, however we get in there. So I don't need an exact because it said approximate it at 615.8 feet cubed. Watch your units because you're dealing with volume. All right, pause the video, work those, come back and check your answers. Okay, I actually showed you step by step. I don't want you copying these, guys. I want you to try and figure out these on your own. If you're still stuck, then go ahead and pause, work your way through them, because we need to be able to find each of the little pieces. Watch when you're finding regular polygon areas, though, because we still need to be in exact before we get to an approximate answer. Alrighty, I'll see you in class.